Assalamualaikum semua. Assalamualaikum and good day to all. Okay, so it has been a long time lah since our last meeting. Okay, I do hope all of you in a good condition. Okay, so I'm still working from home. Okay, so the last meeting we have discussed the 2.1 and also 2.2. Okay, I really hope that you still remember all those things lah, because 2.1 obviously it is theory of the confidence interval. Okay, so you have to nail on the theory lah, so that the rest of the subtopic for the confidence interval it will be easy to understand. Okay, so 2.2 we have discussed the confidence interval for the single population mean. So you have single population. Okay, so 2.3 we have two populations means. Okay, so for the two population mean we have so here we have two objectives. Okay, so the first one to estimate the confidence interval for the difference between two population means of the independent sample when the population variance are known or unknown. Okay, the second one is to estimate the difference between two population means of the dependent samples when the population variance of the difference is known or unknown. Okay, so what is the difference between independent and dependent sample? Okay, so for the two population means we have two cases here. Okay, the first one independent sample and the second one dependent sample. Okay, so independent sample here. Okay, so independent sample means that you have two different data from two different population. Okay, so means that we have two different data which is collected from two different let's say group of subject. Okay, so we have one group of people and we have the second group of people. So the first data collected from the first group of people and the second data collect from the second group of people. Okay, that's independent sample. So dependent sample here, okay, we still have two data. We still have two data. Okay, but those two data we get from similar people, similar subject. If your subject is a people, okay, then those two data we get from similar people. Okay, so dependent sample usually we use for the experimental data lah. Okay, we try to reduce the characteristic of the subject. Okay, then we go to the dependent sample. Okay, so it is more to the experimental data. For example, okay, let's say that we develop the SAFTI program. Okay, and the data that we want to collect to reflect the SAFTI program, let's say that number of accidents happen in industry. Okay, so we have the SAFTI program. We try to see whether the SAFTI program is effective or not. Okay, so what we do, the first data, okay, we collect is the first data we collect before the SAFTI program is implemented. Okay, so let's say that we have 10 industry plant, for example. Okay, so the first data before the SAFTI program, so we collect the number of accidents, okay, at that industry plant, okay, before the SAFTI program, and then maybe 2 or 3 months after that, okay, we implement the SAFTI program and then we collect the data after the SAFTI program was implemented on similar industry plant. Okay, so that's dependent sample. Okay, so the first one, okay, so we will discuss the independent sample first. Okay, so independent sample totally two different data from two different subjects. Okay. Okay, so here we go. Okay, so it will be more a little bit complicated than 2.2 lah. Okay, so 2.2 we have three different formula that we need to consider, but in this subtopic 2.3.1 we have 5 different formula that we have to consider. So how do we consider which formula that we want to use? Depends on the I can say that we have three different conditions that we have to consider in order to know which formula that we have to use. Okay, so the first condition, this one. Okay, so since we have two population, okay, then you will have two different sigma. Okay, you will have two different sigma. So the first condition, it is whether sigma 1 and sigma 2 is known, or sigma 1 and sigma 2 is unknown. Okay, so known here, okay, I'm not sure. Okay, if this formula here is not clear, then you can refer to your module or you can refer to your statistical table. Okay, so because we try to fix all the formula in one screen, that's why it is not really clear. Okay, so sigma 1 and sigma 2 is known means that we do have the value, means that we do have the value of the sigma 1 and sigma 2 in that question. Okay, you can find somewhere in that question the value of the sigma 1 and sigma 2. Then it is a sigma 1 and sigma 2 known condition. Okay, so if known, then we go to the first formula here. Okay, so the first term here, it is a difference between S bar 1 and S bar 2. Okay, so how do we decide which one is the first formula, which one is the second one? Okay, kita nak decide yang mana, nak tolak yang mana. It is depends on the question. Okay, so which one mentioned first in your question? Okay, after this we will discuss the example. It will be the first S1, S bar 1. Okay, the second one mentioned in your question, it will be your S bar 2. Okay, okay, and here we use the Z distribution. So previous class we have discussed how to find the value of Z. Okay, so you can refer to your statistical table, page 36. Okay, so alpha given in that question, it is from the confidence level. For example, that you have 95%, then your alpha is 0.05. So divide by 2, you will have 0.025. So I don't want to discuss anymore why we have to divide by 2. Okay, because we have discussed in 2.1 and also 2.2. Okay, that one it should be clear lah. Okay, cari balik nota lama. Okay. Okay, and then you will have the standard deviation here. Okay, so here we use the sigma. Okay, that's the first formula. Okay, the second okay, so so our first condition is a known or unknown. If you have the unknown case, so unknown case means that you have S1 and S2 in that question. Okay, if you are given data, it is always a sample data. Okay, so from that data you can find the standard deviation, you can find the mean. Okay, if you have sample data, whatever you calculate from that data, it produce statistic. So you will have S1 and also S2. So whenever you have S1 and S2 without the sigma, it is unknown. Okay, so then we decide in this condition, in this question it is an unknown case, so we go to the second condition. Okay, the second condition here, this is a second condition, pay attention. Okay, we need to know whether we have equal population variances or we have unequal population variances. Okay, so this condition, it will be given in your question. You can find somewhere in your question, okay, whether you have equal population variance or whether you have unequal population variances. It is sigma, not the S. We cannot determine this condition by using the formula of S. By using the value of S. No. Okay, it is a sigma. Okay, so it will be given in your question whether you have equal population variance and or unequal population variance. Okay, so after this we go to the example lah. Okay, so after we decide whether we have equal or unequal, then the last condition that we look at is a sample size. Okay, so it will be either both are greater than 30 here or both are less than 30. Okay, dia mesti both, tak ada either one. So both greater than 30 or both less than 30. So you can decide lah. Okay, so if you have equal population variance, okay, so you can see in your formula we do have the SP. So SP is a pool standard deviation. So use this formula lah. Okay, as you know, no need to memorize the formula. You always can refer to your statistical table. But already said in class, you have to know how to use the formula in statistical table. Okay. So when you have unequal population variance here, okay, so sample size greater than 30, then it will be Z distribution. So similar to here, whenever you have n greater than 30, then it will be Z distribution. Okay, so n less than 30, okay, you will have the T distribution. Okay, so we have discussed how to get the T distribution, the value of the T. Okay, it is in page 37 in your statistical table. Okay, for the case unequal population variance here and less than 30, your T here quite special. Okay, the degree of freedom of the T here, the nu here, we have to find by using this formula. Okay, and the nu here, the value always round down. We need the discrete number, okay, nombor bulat. So whenever you get decimal point, then we have to round down, okay, to the next discrete number. For example, that you get nu is a 14.9. Okay, so 14.9, when we round down, it will be 14. Okay, not 15. We use 14 because we have to round down, okay, the value. Okay, 14.1 also round down, we get 14. So use that 14. Okay, so you can find that in your statistical table lah, the value. After you get your nu, let's say 14, then match with the probability value here, then you can find in your statistical table. Okay, after this we go to the example.